Hello, everybody. I will start my today another live coding session. So today I solve this famous typical question LRU cache. So design a data structures that follow the constraint of the least recently used cache. Implement the LRU cache class, which has the constructor, which has the capacity as the argument, initializes the LRU cache with positive size capacity. This is positive and not 0. Okay, let me write it down. So size, no, capacity is positive. Okay. And also it has the get method. Oh, that's the interface. It has the constructor, which takes capacity, which takes the int and returns nothing. Okay. And also it has a get method. And for this get method, it takes the key. Oh, the key is integer. Maybe it doesn't matter, but yeah. Returns the value of the key if the key exists, otherwise return -1. So there should be some object or none. Yep, if the key doesn't exist. Okay. And also it has put method. This takes the key, which is the integer, and value, which is the integer. So get should return integer or null. And value, which should be integer. And because this is the put method, updates the value of the key if the key exists. Otherwise, adds the key repair to the cache. If the number of this key exceeds the capacity from this operation, evicts the least recently used cache. So this put should return nothing. Yeah. And as the side effect, this should upsert the key repair. Yeah. Oh, sorry. This should return the key value or -1. Okay, good. The function get and put must each run in overage time complexity. Get and put takes over 1 time. Okay. So let me take a look at some examples. Let's say I initiate the cache in this way. Yep. In this case, when I when I get something, this should return -1 because this has no key at all. Oh, and I need to specify something. Okay. And if I put something, then it returns nothing, but internally, now cache has the 1 to 11. Okay. And if I try to get something, now this is returned. And if I try to put, say, 222, at this moment, this should return none, but internally, this should have 222 only. Yeah. 1 to 11 is popped out. So if I try to get 1, this returns -1. But if I try to get 2, this should return 22. Okay. And one thing I have to take care is about the least recent access. So if I get or put makes the key the most recent one. Yep. So I have to take care if I put something, that key becomes the recent one. And for get, yes, when I access that, it should be the most recent one. I didn't take care of this in this example, but for example, let's say, yeah, I think I don't have to show the example for this, but I have to take I have to take care of this. Okay, that being said, let me think of the algorithm. So I use the double linked list and hash map in this question. So yeah, double linked list is used like this. This should be node, something like this. So this 11 should point 11.previous should point to none. Yeah. And this one too. 33.next should point to none. And the hash map. So 11 to this is node value. Yeah, like this. Okay, so let me justify this. So if I use the hash map only, yes, get and put basically takes the constant time to put or access the internal hash map. But I have to keep track of the order of the usage internally. And hash map doesn't, hash map can't store the order of the path access. So I need some another data structure. That's why I can't do this only with the hash map. And for double linked list, this is good because I can have the access to the node, okay, with the hash map. And let's say, sorry, and this should also have the key. The key should be 1, key should be 2, key should be 3, and they should point to node 1, 11, 222, 333. Yeah. So the good thing here is, here from this, when I put a new node, sorry, new key value pair, firstly, let's say 444. I create a node and put it in this way into the hash map. Then I can put it to the double linked list. So let's say this should be old, sorry, new to old order. In that case, because 444 is the latest one, I put it here. Then this 333 should be popped out. Let's say capacity is 3. Yeah, in that case, this should be popped out. Now, the good thing is that from this popped out one, which should be at the tail, I can know the key. So with this key, sorry, this should be key. I can delete this from hash map. Yeah. Again, the good thing is of this approach is, number one, I can find the oldest key, or I should say, resprint and reused key value pair immediately from the double linked list. And that enables me to delete it from the hash map. And also, if I have the new element, I just have to push it, or I should say, insert it as the head element in the double linked list, and also add it to the hash map. And when I have the random access, like 2 to 22, from the hash map, I have the access to the node in the double linked list. So I can remove it from the double linked list and then move it to the head. In this way, this 2 to 22 item is thought to be most recently used one. Yeah. Also, I did a double linked list, so I can remove the node and connect, in this case, 111 and 333. These nodes are connected. It's possible. But if this is single linked list, I can't because I don't have the pointer to the previous one. So, I mean, hash map and double linked list completely works here. Okay. So in this way, so time complexity for get, put takes constant. Yeah. Because for get, as I said, I access it from the firstly from the hash map. Then I have the value. And also I have to move it in the double linked list to the head. So I have the immediate direct access to the node. And as I said, what I have to do is remove it from the double linked list and move it, insert it as the head. There's a constant time. For put method, I have to push it into the hash map, then insert it in the double linked list. And if the capacity over, I have to remove the tail node, like 333, and I have the direct access to it immediately from the tail node. Then remove it and remove it from hash map 2. All of them takes the constant time. For space complexity, assuming the capacity is C, it should be O of C, because at max, hash map has C keys and double linked list had C nodes. Okay, so now let me start the implementation. So I have the double linked list, double linked list. Oh, I have to, define the node class too. And because this is the double linked list, step.next is something and step.prev is something. Yeah. Now with this, in the LRU cache method, so I initiate the double linked list head and double linked list tail. And I use the pseudo node here. This is the pseudo head. Yeah, because I don't wanna, take the head node or tail node as the special. Sorry, if there isn't any node yet, I have to treat the head or tail as a special case. That's annoying. So now it looks like this. This is a pseudo node and pseudo tail. And obviously I have to connect this and this. Okay, so now I've done this. And also hash map. I should say key to node. So this is the hash map. Okay, now let me implement the get method. Yeah, for get method, as I said, firstly, I will take a look at the hash map. If there isn't in the hash map, I return -1. And if there is, I have the access to node. Okay, so I should return node.var, but I have to do something. I have to move this node to head. So internally, what I can do is firstly remove the node, then insert as head. So these two phases. So remove the node. What I can do is node.prev.next should be node.next and node, but this is annoying. Let me create a helper method for this. Remove node. So in this way, I will make the operation on the double linked list, which is a lower layer, into another helper method. So I will think of this later. Yeah, now removed. So what I do is insert it into the head. Self dot head. Okay. And I will do this again in the helper method. Okay, now I'm done with the get method. Now I do the put method. Again, what I would do in the put method is, firstly, I have to check if the keyword pair already exists in the hash map. And what should they? Or, yeah. In this way, I have the node. So if there is, my task is to update. Otherwise, what I would do is insert. Yeah. So when I think of this, so when I do update, I can think of this. I can think in this way. When updating, what I can do is remove the existing key completely from the double linked list and also the hash map. Then add it as the new keyword pair, as a new node in the double linked list. So let me do that in that way. So if key is in key to node, I delete it. Then and also remove it from the double linked list. Yep. So this is it. Now I insert it. So I initiate a node. Wait. Yeah. Okay, let me take key value pair into the hash map. When initiating it. Okay, so node should be key value pair. This is a new node, and I push it into the hash map. Oh, So it's been 20 minutes. And also insert it into the head of the direct rest. So now I've done. This is inserted as the head. Yeah. And I have to delete recently used node if capacity over. So if this is over capacity, so I have to have this capacity as the instance variable. It should be only one node above. So I should delete this tail node. Yeah. So I have to remove this tail node. And also I have to remove this tail node from the hash map. Okay. Good. Now I'm done with the, main method. But I have to make this instance variable. Okay. Yeah. So now implements the remove node method. Thanks to the node, to the head and to the tail, this node has actually previous node and later node always. So I can say prev is node.prev, next is prev.next. Prev node.next is next node. And next node.prev is prev node. Okay. In this way, what I did is prev node is pointing to node next, and next node is pointing to, next node prev is pointing to prev node. Good. This node still has the node.prev and node.next value, but this node should be removed and not used at all. So it doesn't matter. Okay. Next, insert as head. This is a pseudo node. And this is the first one. So in this case, what I should do is self.head. This is pointing to the pseudo node. And first node actually is self.head.next. So I insert node between sudo node and first node. Sudo dot next point to node dot prev sudo node, and node dot next is first node. First dot prev should be node. Okay, so this is it. Good. So let me quickly dry run my code. So let's think like this. Capacity is 1. Maybe this one is good. And I try to firstly put something. Yep. I think this is quite simple example, but let me work through this first and check the remaining uncovered code carefully with maybe some example, or maybe just reading the code. Okay. So the first thing, in initiate method, self.capacity is 1. Self.head is pointing to the pseudo node, and self.tail is pointing to the pseudo tail. Yes. And in line 65, head.next is tail. Yes. Tail.next is tail.previous head. Good. And key to node, this should be an empty hash map. Good. And I call the get method with key 1 for 3 in line 43. Expected -1. Yep. So for the get method, key 1 doesn't exist in the key to node. So I go to line 73 and return -1. Good. I passed this one. Okay. For this one, when I put this, this should return none. The put method, key is 1. Key is not in self.key to node. I go to line 86. Node is initiated with, sorry, it should be 111. 111. Where is it? Yeah, this one. Okay. Self.hashmap key is equal to node. Okay. Then insert as head node in line 76. So this node 111 is inserted as the head node. Okay. This is just a reference. Okay, good. And where is it? So I've done line 88. So I go to line 91. Delete LRU node if capacity over. Length of saved node to var. No, this should be key to var. Yeah, this should be 1. Saved capacity is 1. So it doesn't exist. Then that's it. Okay, looks good. So put method, this passed. And in line 45, if I get, this should expect it to return 11. So get 1, I come to here. 1 is in the hash map. I go to line 74, and I get the access to this node, 1. So insert as head, sorry, in line 75, remove node. Hmm? I see. So this node 1 is deleted, and then insert it as the head, so it comes back here. And in the end, I return node.bar, which is 11. I passed this test case. So this example looked real naive, but at least I could cover all the lines in get method, in constructor method, and put method, aside from line 80 to 83 and 92 to 96. Yeah. So yeah, let's think of the case when I get the put 122 quickly to cover line 82 to 85. So key is yes inside of the key to node because key 1 exists. So node is self.key to node key. So this should be node 1. And then line 84, remove node. So this one is deleted. And then line 85, I delete this key-value pair. So now the double ring trace and hash map is completely reset. And I go to insert method. I've already covered it. I will go quickly. This has now 1 to 22 in the hash map and also as the head node. Yeah, and that's it. I couldn't cover the case when the capacity over. Let me quickly check line by line. So if hash map has one more element than capacity, I take a look at the tail node, which should not be the pseudo node. Pseudo head, pseudo tail, obviously. And then in line 96, remove it, and also remove it from the hash map. Okay, looks good to me. So I covered those lines. I'm pretty confident in my code. I couldn't cover these lower layer methods, helper methods, but let me check it if something goes wrong. Let's submit my code. Oh, hash no. Key to node. Key to node. Key error. Ah, I see. This should be tail node dot key because I have to delete the key from the hash map. Okay, accepted. Good, accepted. Great. Okay, so let me quickly wrap up. So today I solved the very famous question, LRU Cache. So this is in this question, I had to implement the LRU Cache, which has basically stores the key value pair, but if it exceeds the capacity specified, I have to remove the key value pair, which is least recently used. And in this question, I used the combination of double ring trace and hash map. So in that way, I could implement get and put method so that they work in O1, constant time complexity. And the reason why I use double ring trace additionally to hash map is because basically key value pair can be stored in a hash map, but I have to also keep I have to keep track of the order of the nodes in terms of the access age. Yeah. So access order. So this double ring trace keeps track of the order. When I have to remove the least recently used one, I had to just remove the nodes from the tail. And because I know the key of the node, I can remove it from the hash map too. Or if I have the random access to the hash map, which means that I have the node reference direct access. So I have to remove the node from the double ring trace and insert it as a head. Or if I have to create a new key-value pair, key-value item, I create the node and insert it as the head in the double request, and also add the reference from key to node in the hash map. Okay, so that's why I use the double request. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.